Hi everyone, so today I'm going to discuss about the integrals of exponential and logarithmic functions. So far we have learned about power rule, especially if we are given an integral of the type x to the power n, how we can integrate it, we know it, how to do it. And then we discuss about some specific kind of functions such that integrals of fx to the power n by using the same way. But today I'm going to discuss about integrals involving exponentials and logarithms. So these are the exponential and logarithmic functions. Uh, Basically, here I use this formula e to the power u times u prime dx, or sometimes it may be in this type. And secondly, if we are given some rational type of function such as fx divided by gx, in here the specialty is always in here u is our original function and this is u prime, or otherwise 1 over u. So I'm going to discuss about integrals of such kind of functions. First let's move to exponential functions. So this is the first topic, integrals involving exponential functions. So already we know that if we take the derivative of e to the power x with respect to x, it is equal to e to the power x. And then we learn that derivative of e to the power u. Here u is a function of x, or sometimes it may be a function of t, or a function of y or something. The corresponding integrals are given by the following. So directly, this is the most simplest one. E to the power x dx is equal to e to the power x plus c. So if any place, if you see such kind of integral, then at the first glance you can write it as e to the power x plus c. And this is little bit complicated one. So if you go to here, you can see integral of e to the power u times derivative of u dx. So when you are seeing a problem, you need to see very cautiously and you need to understand what is your u and what is your u prime. So if you can understand, then you can convert it into this type. So but when you're writing the final answer, this is not compulsory. Important one is this one. Then finally you can write e to the power u plus c. So now let's move to some examples, then you can understand this concept. Okay, so this is my first problem today. Let's see how we can do it. 2 times x times e to the power x square dx, how we can do it. So first look at the problem very cautiously. Now you can see this is in the type of e to the power u. So what is your u in here? Your u is x square, and here you can see 2 times x is the derivative of u with respect to x, so it is u prime. So now already you have e to the power u, this one, and u prime 2x. So we can use this formula, e to the power u times u prime dx. So this is e to the power u and this is u prime. I can explain like here. So you can write the final integral as e to the power u plus c, and now replace this u with x square. So finally this is your answer, e to the power x square plus c. So it is very easy and simple problem. Especially here the most trickiest part is distinguish what is my u and what is my u prime. If you can distinguish these both very easily and fastly, then you can done your problem very well. So let's move to our next problem. It is little bit tricky. So at the first glance you can see it is in a rational type, but by taking this part e to the power x to the power 3, you can convert in this form. So here also you need to understand, here you can see e to the power something. So here I do this way. So I will take my u is equal to negative x to the power 3, then take the derivative of here u prime, so it is negative 3x square. But if you look at the original problem, you can see any 3x square, but here only you have x square. So now I am going to fix this negative 3x square in here. To avoid this negative 3, I divide the whole problem by negative 3. That is why I have multiplied this by negative 1 over 3. Now this is equal to this one. So negative 1 over 3 is a constant, no need to worry about it. You already have e to the power u times u prime. Then you can write your final answer as negative 1 over 3 times e to the power u. So your u is negative x to the power 3. So this is the final answer. This is an application problem. Sometimes in the exams it can be asked, you are given some day-to-day life activity or some application in business or economy, then you need to solve that problem by using the knowledge of derivatives. So here the problem. Suppose the rate of change of the value of a house that cost 20,000 in 2015 can be modeled by dv over dt is equal to 15.4 times e to the power 0 e to the power 0.077t, where t is the market value of the home in thousands of dollars and t is the time in years since 2015. So first it is asking find the function that expresses the value v in terms of t. So definitely you need to understand a problem. So here it is asking you need to find the value of y. So what is your v? You need to find the value of v by the terms of t. And secondly, in part B it is asking find the predicted value in 2025. It means after 10 years what is the value of v. Okay, so this is a new problem for you. To solve this problem I use mainly 3 steps. So here our final goal must be to find what is the v. So this is the given information. First, find the differential. You already have learned how to find a differential. To take the differential of dv, I multiply both sides by dt. Dt I multiply in here and I multiply here by dt. So here this dt is cancelled with this dt, and then it becomes like this way. dv is equal to 15.4 e to the power 0.077t times dt. Okay, now we already have found what is the differential or dv. Then start to integrate both sides. So I differentiate this side and I differentiate this side. Sorry, integrate this side and I integrate this side. Then if we integrate dv with respect to v, it becomes v. It's a very simple one, and this is the thing you need to integrate. So then let's move to our next section. So we need to integrate this one. So here you can see this is e to the power u. So this is u, and now you need to multiply this by u prime. But this is some value we taking by our hand, so we need to divide to cancel that value. So this is a constant and this is a constant. So I am taking these two constants outside from the integral sign. So this is some constant, put it outside. Now this is the problem. So you know this is e to the power u, and this one is e to the power u, and this is our u prime. So now we can write our final answer as e to the power u plus c. So this is e to the power u and plus c, and this is coming from this constant, so it is 200. So this is the answer for the value of v in terms of t. So we already have find the value of v in terms of t, but already we know what is the value of c. To find c, we can use some initial condition, that is when t is equal to 0, v is equal to 200. Then substitute these values in that our formula v, then you can find our c is equal to 0. So finally we can get this is the value for v in terms of t. After that problem asking after 10 years what happened to this v. So we have to substitute 10 for this t, then it becomes this value, and by using your calculators you can find it. So thus in 2025 the predicted value of the home is this amount. Okay, now let's move to the next section. So basically in here we are discussing about integrals involving logarithmic functions. The trick in here is always you have to consider the rational functions. If we are seeing a rational functions, we can do two methods. First one is we can take the denominator into the numerator, and secondly, if it is impossible, or if we can do it, we can use this method. So it has basically two formulas. First one is u prime divided by u dx is equal to ln u plus c. Here don't forget to put this modular sign, it is very important in this kind of problems. And if we get a problem in 1 over x dx, in simply we can write ln x plus c. Okay, let's move to examples. First one is evaluate this one. Oh, so by looking at this one we can understand this is a rational type integral. So think this is a u. If this is your u, then take the u prime. So u prime is equal to 4. Now we can see this is the u prime. So now it is in the type of u prime divided by u dx. So we can use this formula. Then directly we can write the answer as ln modulus of u plus c. So your u is this one. So finally it is become ln 4x plus c modulus plus constant. In here the meaning is for this constant we can use several number of values. It may be 5, 6, 7, 8 or some value. Okay, thank you everyone, and let's meet on this Wednesday from the next section 12.4. Thank you for all of you.